Welcome to The Explainer. Today, we're jumping straight into a critical, potentially life or death component of industrial safety that honestly is frequently misunderstood until it's far too late. We're talking about the confined space program. Now, when most people hear the phrase confined space, they picture, a tight supply closet or a narrow hallway. But in a manufacturing setting, confined spaces aren't just tight rooms. They are potentially lethal environments hiding serious atmospheric and mechanical hazards. We're talking about areas where oxygen levels can drop completely silently or where mechanical engulfment is a very real, very present danger. So today, we're breaking down the standard operating procedure that governs these high-risk areas to see exactly how facilities keep their teams alive.
Okay, let's dive into this. The Confined Space program really relies on 4 operational mandates: localized appendices, mandatory stenciling, lean team roles, and emergency rescue verification. Let's look at how these 4 pillars come together.
Starting off with Pillar 1, localized appendices, and how we go about identifying your plant's unique hazards.
So, because every single plant's physical footprint is totally different, a massive corporate master list of confined spaces simply doesn't work. To build a localized appendix, a facility first has to classify its spaces with absolute zero ambiguity. On one hand, you've got permit-required spaces. These are your danger zones with potential atmospheric hazards or engulfment risks. And on the other hand, you have non-permit spaces, which, yeah, they might be tight, but they critically lack those life-threatening hazards. Mixing these 2 categories up, that is an absolute recipe for disaster.
And this right here is exactly why location matters. Let's say one of your facilities has a piece of equipment called a cyclone. Well, entry inside that cyclone is automatically classified as a permit-required space. But what if a sister plant doesn't even have a cyclone? They might just have a Komori press, a sheeter delivery area, or facility balers, all of which are classified as non-permit spaces. If you just copy and paste a master list from one plant over to another, it is completely invalid. Employees absolutely must consult their specific site's localized appendix to know exactly what hazards they are dealing with. Moving right along to Pillar 2, mandatory stenciling. This is where we move from paperwork directly out onto the floor.
Look, you can have the best, most detailed safety appendix in the world, but if the operator standing right in front of the machine doesn't know they're looking at a permit-required space, the whole system fails. So what's the solution? We replace confusing text tables with mandatory on-machine stenciling. When a worker walks up to a hazardous access point, they don't have to guess or try to remember a manual they read 6 months ago. The machine itself is literally telling them, danger, permit required. Seeing this stencil means one thing, and one thing only: stop. Employees have to stop, look, and verify. It acts as a hard physical prompt to initiate the formal safety workflow. You cannot just open the hatch and crawl inside to clear a jam. This stenciling prevents accidental or, honestly, even complacent entry into lethal zones by forcing the operator to pause and assemble the required safety team.
Next up is Pillar 3, the lean team roles, focusing on the strict division of labor. Now, what's really interesting about this setup is how clearly it maps out responsibilities. Safe entry into a permit-required zone is never a one-person job. Never. It requires a highly structured division of labor. You've got the QI manager acting as the records keeper, ensuring all those formal program records are compliant. Then, the plant manager steps into the crucial role of entry supervisor for the actual permit sign-off and hazard evaluation before anyone even sets foot inside. And finally, your maintenance team takes on the dual roles of space attendant and entrant. One person goes in, while the attendant stays outside for active monitoring and atmosphere testing. Speaking of atmospheric testing, here is a number you absolutely have to know: 19.5%. That represents the absolute minimum safe oxygen threshold. These confined spaces, they can trap invisible, toxic chemical vapors or simply lack enough breathable air. During their mandatory atmospheric testing, the maintenance team has to watch their meters like a hawk. If that oxygen level drops to 19.5% or below, we're talking about an oxygen-deficient lethal atmosphere. The space must be evacuated immediately. Which brings us to Pillar 4, emergency rescue verification. This is your final safety net. We really need to talk about what happens when all the preventative measures fail. When things go totally sideways, who actually rescues you? Think about that for a second. If you're assuming that local authorities can just show up and save you without any prior verification, that is a fatal mistake. You cannot just dial 911, sit back, and assume a standard fire engine crew has what it takes to pull an unconscious worker out of a highly complex industrial machine. Because the reality is, industrial extractions are incredibly complex operations. They require specialized tripods for vertical lift, high-powered ventilation systems to clear out toxic atmospheres, and advanced industrial extraction gear. The strict rule within the confined space program is that plants must formally evaluate and verify that the local fire department actually possesses this highly specialized gear before relying on them. If your local municipality isn't equipped for a vertical industrial extraction, you simply cannot list them as your emergency responder. You've got to make other arrangements.
Let's bring this all together and see how this builds into a complete sequential flow from start to finish. Step 1. Evaluate the hazard via your local appendix. You check the specific list for your exact plant. Step 2. Assemble the lean team for entry. Get your QA manager, plant manager, and maintenance team in position to authorize and monitor. And step 3, verify your emergency rescue capabilities so you know for a fact that if the worst happens, the people coming to save you actually have the tools to do it. So, I want to leave you with one final vital question. Is your specific plant truly ready for its next confined space entry? Don't just assume. Go check your physical machines for those stencils, verify your own local appendices, and confirm your emergency contacts today. Safety isn't just some binder collecting dust on a shelf, it's a constant, active process. Thanks for hanging out with me for this explainer, and please stay safe out there.